In this problem, we have an 800 kilogram beam that's being supported by two ropes, one at 20 degrees from the normal, one at 30 degrees from the normal. Now, in this problem, nothing is moving. If we look at our equation, F equals ma, because nothing is moving, the acceleration equals 0. If the acceleration equals 0, that means the net force equals 0. So if we add all of the forces that are acting in this system, all of them will equal 0. So all of the forces in the y direction, they have to equal 0. All of the forces in the x direction, they have to equal 0. Now, if we were to replace that drawing with a force diagram, we have rope 1, which is on the left. We'll call that tension 1. So the force in rope 1 is tension 1. The force in rope 2 is tension 2. Now rope 1 is 20 degrees from the normal, which means that it's really 70 degrees from the x-axis. Rope 2 is 30 degrees from the normal, which means that it's 60 degrees from the x-axis. So if we add an x and a y axis, you can see how the vectors would look on those axes. The 800 kilogram beam would be represented by a 7,840 Newton force that's pointing straight down. Okay, now we want to break down tension 1, rope 1, into its x and y parts. So it has an x part, it has a y component to its vector. Rope 2, we're going to break it down into its x and y parts. So there's an x component and a y component to that vector. And the beam, the force is pointing straight down. There is no x component, only a y component. So what we need to do now is we need to look at all of the forces in the x direction, all of the forces in the y direction. And for rope 1, I already showed you, the force in the x direction is the tension in that rope times a cosine of 70. Now it'll be negative because it's pointing to the left. And if you go left from the origin on the x-axis, that's negative. In the y direction, that component will be T1 times the sine of 70. Now for rope 2, in the x direction it'll be positive. It'll be T2 times the cosine of 60. And in the y direction, it'll be T2 times the sine of 60. And the beam, we already stated in the x direction, the force will be 0. In the y direction, the force will be negative 7,840 because it's pointing down. And on the y-axis, if it goes down, it's negative, up it's positive. So for f of x, if I take the cosine of 70, that's 0.342. The cosine of 60, that's 0.5. So negative 0.342 T1, because it was pointing to the left, plus 0.5 T2 equals 0, because all of the forces in the x direction have to equal 0. If I want to solve for T1, I could say 0.5 T2 equals 0.342 T1. So I just moved 0.342 to one side of the equation. Now in the y direction, all of those forces have to equal 0. So 0.94 T1 plus 0.866 T2, because sine of 70 was 0.94. The sine of 60 is 0.866. So 0.94 T1 plus 0.866 T2 minus 7,840 equals 0. If I move the 7,840 to the right side, I end up with 0.94 T1 plus 0.866 T2 equals 7,840. Now, what I want to do is solve for T1 and T2. That's the tension in rope 1 and the tension in rope 2. So the first thing I'll do is I'll take the x parts of the force, and they're already set equal to each other. 0.342 T1 equals 0.5 T2. I will solve that for T1. So I divide both sides by 0.342, and I have T1 equals 1.46 T2. Now, I'm going to take the equation from the y part. So I have two equations, two unknowns. I have 0.94 T1 plus 0.866 T2 equals 7,840. I will now plug T1 into that equation. So I have 0.94 times 1.46 T2, because T1 was 1.46 T2, plus 0.87 T2 equals 7,840. Now, I'll combine like terms. Well, actually, the first thing I'll do is multiply. So 0.94 times 1.46 was 1.37 T2 plus 0.87 T2 equals 7,840. Combine like terms. 2.24 T2 equals 7,840. I want to get T2 by itself, so I'll divide both sides by 2.24, and I end up with the fact that T2 equals 3,500 newtons. Now if I know T2, I can calculate T1, because T1 was equal to 1.46 times T2. So I will plug 3,500 in for that. So T1 equals 1.46 times 3,500. Multiply those out, and T1 equals 5,110 newtons. So the tension in rope 1 is 5,110 newtons. The tension in rope 2 is 3,500 newtons. And they'll support the beam. Now, as long as either of those ropes can support at least the amount of force that's in them. So if the rope 1 can support 5,110 newtons, it will not break. If rope 2 can support at least 3,500 newtons, it will not break. And that's how we find the tension in both ropes.